Hello everyone, my name is Gopikadi and I'm studying in 7th Sem ISC in SVCE Bengaluru, and the topic I'm going to tell you about is environmental impact of underground pipeline. Introduction. Underground pipelines are essential for transporting resources like oil, gas, and water over long distances, providing critical infrastructure for energy and utilities. However, these pipelines can pose significant environmental risks if they leak or corrode, releasing harmful pollutants into the surrounding soil, groundwater, and sometimes even into the air. This presentation explores a case study focused on measuring pollutant concentrations within an underground pipeline, aiming to understand the impact these pipelines can have on ecosystems and public health. By examining pollutant levels and their effects, we can identify risks, develop better monitoring methods, and implement policies to reduce environmental harm and protect communities. Pollutants overview. Main pollutants from pipelines. Underground pipelines often leak various pollutants, including hydrocarbons, heavy metals, and chemicals. This contamination poses severe risk to ecosystems and human health. Case study summary. Findings. Main findings indicate significant pollutant levels near the pipeline site. The study recommends urgent action to mitigate. The case study examines a pipeline in a sensitive ecological area. It highlights how pollutants reach local waterways, affecting flora and fauna. Pollutants detected. The study identified various pollutants in the soil and groundwater. Surrounding the underground pipeline, heavy metals such as lead, cadmium, and arsenic were found in elevated levels, which are known for their persistence and potential to cause long-term ecological and health effects. Hydrocarbons, including benzene, toluene, and polycyclic aromatic hydrocarbons, were also present, indicating potential leakage from petroleum-based materials. Environmental impact: soil quality, water quality, ecosystem disruption. Health risks. The study highlighted severe health risks for communities in close proximity to contaminated areas. Heavy metals pose risks such as neurological damage, kidney issues, and developmental impairments, particularly affecting children. Exposure to hydrocarbons like benzene is associated with respiratory problems and an increased risk of cancers. These pollutants can also lead to indirect health impacts through food and water contamination. Pollution sources and causes. Pipeline corrosion and maintenance. Corrosion was a major contributor to pollutant leakage, exacerbated by aging infrastructure and lack of adequate maintenance. Chemical additives. Chemicals added to reduce corrosion or improve pipeline function were found to contribute to soil and water contamination over time. This case study illustrates the complex and far-reaching environmental impacts of underground pipeline pollution, emphasizing the need for proactive management strategies and minimize risk to ecosystems and public health. Pollutants table. This table summarizes the concentrations of key pollutants detected near underground pipelines and their potential sources. Regular monitoring is essential. In the table, you can see three columns named as pollutant concentration and source. Benzene 0.5 leaking pipeline. Lead 2.0 corroded pipes. Toluene 1.5 industrial runoff. Naphthalene 3.0 transport effluents. Impact on environment. Effects on ecosystems and health. Pollutants from pipeline leaks can devastate local ecosystems, harming wildlife. They can also contaminate water supplies, posing serious health risks to nearby communities. Underground pipelines can significantly impact the environment when pollutants such as hydrocarbons and heavy metals leak or seep from the pipeline into surrounding soil and groundwater. These pollutants can disrupt local ecosystems by contaminating soil, which affects plant growth and can enter water sources, posing risk to aquatic life and wildlife. In cases where groundwater is contaminated, this pollution may impact drinking water supplies, posing health risks to nearby communities. Statistical analysis: 50% heavy metals contribution, 30% hydrocarbons contribution, 20% other chemical pollutants. Heavy metals contribution. Heavy metals are significant contributors, primarily from corroded pipes. Heavy metals are among the most concerning pollutants that can leak from underground pipelines, especially those used for transporting oil or gas. Metals like lead, cadmium, mercury, and arsenic can leach into the surrounding soil and groundwater, posing long lasting environmental risks. Once in the soil, these metals can be absorbed by plants, entering the food chain and impacting animals and humans alike. In groundwater, heavy metals can accumulate over time, leading to contaminated drinking water supplies, which may cause severe health issues such as kidney damage, neurological effects, and developmental issues. Unlike organic pollutants, heavy metals do not easily degrade, making their environmental presence persistent and hazardous. This makes monitoring and preventing heavy metal leakage critical to minimizing ecological harm and protecting community health. Hydrocarbons contribution. Hydrocarbons account for half of the pollutant types found, mainly from leaks and spills. Hydrocarbons, primarily derived from petroleum products in pipelines, are a major pollutant that can have severe environmental consequences. When hydrocarbons leak, they can spread through the soil and reach groundwater, contaminating these resources and impacting ecosystems. Hydrocarbons in soil can inhibit plant growth, disrupt soil microbes, and reduce biodiversity by making the soil environment toxic for many organisms. In water, hydrocarbons pose risks to aquatic life as compounds like benzene, toluene, and xylene can harm fish and other wildlife, often leading to bioaccumulation within the food chain. Additionally, volatile hydrocarbons can release into the air, affecting air quality and contributing to smog formation due to their toxic, carcinogenic, and persistent nature. Controlling hydrocarbon leakage is crucial to safeguard both environmental and public health. Other chemical pollutants. Other chemicals make up 20% stemming from industrial operations. In addition to heavy metals and hydrocarbons, underground pipelines can leak other harmful chemical pollutants that affect the environment. These may include sulfur compounds, chlorinated solvents, and various additives used to prevent corrosion or improve flow efficiency. When released, sulfur compounds can contribute to soil acidification, impacting plant growth and soil health. Chlorinated solvents, often found in industrial pipelines, are highly toxic and can cause groundwater contamination, leading to adverse effects on both ecosystems and human health due to their carcinogenic properties. Pipeline additives such as anti-corrosion agents and stabilizers can also leach into the environment, disrupting microbial ecosystems and affecting soil and water quality. These chemicals, although often present in smaller quantities, can have significant cumulative and synergistic effects, amplifying environmental damage. Monitoring and managing these pollutants are essential to minimize their impact on ecosystems and reduce potential risks to human health. Mitigation strategies. Regular inspections. Conducting scheduled inspections can help identify leaks early, reducing the impact on the environment. Advanced materials. Using corrosion resistant materials in pipeline construction can minimize leakage over time, protecting ecosystems. Emergency response plans. Developing robust emergency response plans ensures quick action against potential leaks, limiting environmental damage. Recommendations. Enhanced monitoring systems. Implement real-time leak detection and monitoring systems along pipelines to quickly identify and address leaks, preventing pollutants from spreading to soil and water. Routine maintenance and upgrades. Conduct regular inspections and preventive maintenance on pipelines to minimize corrosion and wear, especially in older pipelines. Stricter regulatory standards. Enforce stronger regulations to ensure that pipelines are designed, built, and maintained according to high environmental standards. Improve pipeline materials and technology. Use advanced materials that resist corrosion and reduce the likelihood of leaks, especially in pipelines transporting hydrocarbons and other hazardous chemicals. Emergency response preparedness. Develop and regularly update emergency response plans tailored to potential leak scenarios, including containment and remediation strategies. Conclusion. The environmental impact of underground pipelines, particularly concerning pollutant concentrations, present significant challenges that must be addressed to protect ecosystems and public health. This case study highlights the prevalence of harmful contaminants, including heavy metals, hydrocarbons, and various chemical pollutants, which can seep into the soil and groundwater. posing risk to both the environment and local communities. The findings underscore the critical need for enhanced monitoring, routine maintenance, and stricter regulatory measures to prevent leaks and mitigate the effects of contamination. By implementing comprehensive strategies for pipeline management and engaging with affected communities, we can better safeguard natural resources and public health. Ultimately, proactive measures will not only minimize environmental harm but also foster greater trust and collaboration between pipeline operators, regulatory bodies, and the communities they impact. Thank you.